we're going to be given some polynomials that will be like 5th degree polynomials or something like that. And we still need to be able to find the roots of them. We still need to be able to factor them. Okay? And so we can't do that with conventional methods. We don't have, none of our tricks that we've learned as far as factoring goes will work for those that have more than 4 terms. Okay? And so, or if you have a polynomial that has 4 terms and you can't factor it by grouping. Okay? And so yesterday we talked about how do we know if something is a factor. If something is a factor, then we divide and we check for a remainder. If the remainder is 0, then that means it is a factor. Okay, well that holds true for polynomials. Okay, just like regular numbers, we know the factors of 12 are 3 and 4. So if I take 12 and divide it by 3, it's going to equal 4. There's not going to be any remainder. Okay, if I take any fraction, if I take another example would be if I had 11 and I divided by 3. Okay, 11 divided by 3, 3 goes into 11. 3 times with how many left over? 2 left over, right? This is my remainder. 2 is my remainder, okay? You need to remember these very basic principles, okay? When you have something divided by something else, okay? You take your bottom, you divide it into your top. However many times it goes is the whole number. And then it's your remainder over what you divided by. That concept is going to come into play in a few examples down the road. Okay? But is 3 a factor? No, it's not. Because there was a remainder, 3 is not a factor. Okay? So we need to think about that simple principle moving forward. Okay? So when we're talking about polynomials, the example I gave was if we took x squared plus 8x plus 15 and we factored it using our AC method, we would get x plus 3 times x plus 5. Now, we know that x plus 3 is a factor and x plus 5 is a factor. Factors are things you multiply together to equal what you started. Likewise, if x plus 3 is a factor, then x equals negative 3 is a solution to that polynomial. Okay, because we take those factors, we did in the last section, we took those factors, we said each factor equal to 0, and we found the solution. Okay, so you need to keep in mind, how does this flow work? We go from polynomial, then we factor that, right? And then we get the factors. From the factors, we get the solutions. From the factors, we get the solutions. At the end of chapter 6, we're going to be able to go backwards with that also. They'll give us the solutions. Given the solutions, we'll write the factors, and then we'll multiply those factors and get the original polynomial. You need to be able to go back and forth between those 3. And in order to do that, you have to truly understand what they are. Okay? And so that's what I'm going to attempt to try to help you do. So, if x plus 3 and x plus 5 are factors of this polynomial, then that means if I take the polynomial and divide it by one of them, my answer is going to be the other one. Okay? And vice versa. If I take x squared plus 8x plus 15 and divide it by x plus 5, my answer is going to be x plus 3. Okay? And you don't know how to do that yet, but I'm going to show you how to do that. How to actually divide that. Okay? So, you have 2 different methods to be able to divide these polynomials. You have long division and you have synthetic division. Synthetic division is short. It's a much shorter process. Long division is probably something that you're more familiar with because we know how to divide regular numbers. And those steps are exactly the same when variables are included. Okay? And so, if I have to take the same example we were just looking at, x squared plus 8x plus 15 divided by x plus 3, it could either be written as a fraction like this, that means this divided by this, right? Or it could be written out linear, using the regular division symbol. Okay, both of those are saying the polynomial divided by one of those supposed factors. Okay? And so we already know that once I do this, my answer should be x plus 5, because we factored in on the page before. Okay? And so let me show you how to do long division with polynomials. Now, the first thing you need to make sure is that every exponent is represented. So if your highest exponent is 2, you need to have an x to the first power. And then you need to have a constant. Okay? If any of those are missing, you need to put placeholders in the form of 0x or just plus 0. Or if it started with x to the third and there was no x squared term, you need to add in plus 0x squared. You have to have those placeholders, because when we do this process, what's going to happen is we divide, then we multiply, then we subtract, then we bring down. That's how we do it, right? That's how we divide. Well, when you multiply, you're not going to have, if you're missing one of those terms, you're not going to have anything to line it up underneath, and it's going to mess you up. You're going to be like, I don't know what do I do? And so you have to put your placeholders in. That's true for long division or synthetic division. Okay, you have to have those placeholders. So check to make sure that none of your terms are missing. Okay? And none of them are missing here. We have x to the 1 is our highest exponent here, and we have our constant. And then x squared, this is x to the 1, and then our constant. Okay? And so now we just divide. So we look at x. You would normally say that goes into that how many times? Well, we're doing the same thing. Okay, we're doing the same thing, but sometimes it's harder for people to think about how many times x go into x squared. Well, what you need to think about is the answer that I put right here, when I multiply, I need to get x squared back. Okay, so think about this. X times what is x squared? X, okay? So x goes into x squared, x times, because, let me erase this box because I don't want to keep that there. Okay? Now I'm not paying attention to the 3. I'm just looking at first term into first term. Okay? Now I need to multiply. But when we're dealing with polynomials, it's really like distributing the 3. Because you don't just multiply it to the first term. You have to multiply it to x and also to 3. But you do that individually. So first we multiply x times x and we get x squared. You should get exactly the same thing as that first term. Every single time. If you don't get exactly the same thing, you didn't do something right. Okay? So we multiply x times x and we get x squared. Now we multiply x times 3 and we get positive 3x. Okay? Remember, these steps are just like regular long division with numbers. Okay? So we divide, we multiply. What's the next step? You would subtract, right? You would subtract. Well, we can't just, they're variables. So we're not, even when you were subtracting the regular numbers, what you're doing is you're taking that number and you're changing the sign. Okay? And so, again, we're going to subtract this polynomial, but what do you think is going to happen when I subtract this? What's going to happen to both of these signs? Both signs are going to change. So that's the only thing that's a little bit different as opposed to regular numbers. The subtract step means change the signs of both of these. Okay? So this is going to become negative x, and this is going to become negative 3x. So that's the subtract step. So now we combine these terms. Your first term should always cancel every single time. Okay? And so now 8x minus 3x is what? 5x. What's the next step? Bring down, right? Divide, multiply, subtract, bring down. So we're going to bring down the next term. Now, yes, I'm still using that. So now, if it was regular numbers, what will we do next? You divide again. You take this and divide it into this, right? That's the natural process for long division. It's still the same. So we're going to say x x goes into 5x. How many times? Which means, what do I have to multiply x by to get 5x? 5. So it's a positive 5, so we put plus 5. Now what? Multiply. So we're done with this. So now we're going to multiply both of these by 5. So 5 times x is 5x. 5 times 3 is positive 15. Multiply. Now what's the next step? Subtract, which means change all those signs down here. Okay? So when I change the signs, that's going to become negative 5x, and that's going to become negative 15. Right? And so these cancel, but these also cancel, leaving me with 0. What's this?
The remainder?
The remainder. So my remainder is 0. My remainder is 0. What does that mean? Very good. Oh, I'm so glad to hear y'all say that. That means that x plus 5 is a factor. That means that x plus 3 is a factor. Our answer is x plus 5, which is the other factor. Okay? Because think about it. When you say 3 goes into 12, how many times? And we know the answer is 4, right? 4 times 3 is 12. My remainder is 0. 12 is equal to 4 times 3, since they're both factors. So x squared plus 8x plus 15 is equal to x plus 5 times x plus 3. They're both factors because the remainder was 0. Yes?
So if you have the remainder and then you got x plus 3 going in, x plus 5 those factors, what would be the solution?
Okay, so our factors now, what do we just do? So we say x squared plus 8x plus 15 is equal to our two factors, x plus 3 times x plus 5. So this is equal to this. So how will we find the solutions? Set each factor equal to 0. So the first solution is negative 3, and the second solution is negative 5. Do y'all remember when we were looking at vertex form, and we were picking out the vertex of a quadratic, right? And I said if it's in the grouping symbol, it's the opposite sign. Same thing. Negative 3, negative 5. So yes, once you find the factors, if the directions say find the solutions, you take each factor and set it equal to 0. But I just don't want you to forget that what you're dividing by is your first factor. If the remainder is 0, that is your first factor. Your answer is the other factor. Okay?
So we're not trying to get the solutions at the bottom. We're not trying to get negative 3, negative 5.
No, right now we're just trying to factor this using synthetic division. Using regular long division. So I want you to try this when doing long division. Let's go over this. Okay, so x goes into 2x to the third, 2x squared times. Now, some people are forgetting they're multiplying their answer times x, but they're not multiplying it times the second one. It's a binomial. It's like we're taking 2x squared and multiplying it times x plus 3. If you're multiplying it times x plus 3, that means you're distributing. So you have to multiply both of those terms by 2x squared. So 2x squared times x is 2x to the third. 2x squared times 3 is plus 6x. Now, the next step is to subtract. So it's like we're subtracting the whole polynomial. And if we're subtracting an entire polynomial, that's changing both of the signs. It's like multiplying both of them by negative 1. This is negative 2x to the third, but this changes to negative 6x. Okay? And so this cancels. It has to every time. If that doesn't cancel, you didn't do something correctly. And so now we're left with negative 6x. So now I've subtracted. The next step is bring down.
It wouldn't be a negative 6x squared.
Yes, it is absolutely a negative 6x squared. Good job. Very good. Okay, so negative 6x squared. Now we bring down. Some of you were bringing down before you subtracted. It's divide, multiply, subtract, bring down. Okay? Bring down negative 2x. Now we do it all over again. Now we divide. X times what is negative 6x squared? Negative 6x. Okay? So, now I'm multiplying negative 6x times x plus 3. So, negative 6x times x is negative 6x squared. Negative 6x times 3 is negative 18x. That was multiply. Next is subtract. So I have to subtract this whole polynomial. So this is going to become positive 6x, and this is going to become positive 18x. I'm still in the subtract step. Just because I added the subtraction sign doesn't mean I actually subtracted. So now I'm going to combine my terms. That has to equal 0. That has to happen every time. And so negative 2x plus 18x is 16x. Now I'm done subtracting. Last step, bring down. Bring down the plus 48. Now I have to divide. X goes into 16x how many times? 16. Positive 16. Now I have to multiply 16 times x plus 3. So 16 times x is 16x. 16 times 3 is positive 48. Now I multiplied. Now I have to subtract. So when I subtract, it changes both of these to negative, canceling both of those out, which means my remainder is 0. So if my remainder is 0, what does that tell me about x plus 3? It's a factor. What do I know about 2x squared minus 16x plus 16? It's another factor. Because if I take that and multiply it times x plus 3, it's going to equal the original polynomial. Yes.
Another like the slow thing, like, because you know, the last one is positive, and then when you like, you know how you have to put it back into its original form, which is like factor it all out.
Yes. Yes. And so what I want you to realize at this step, you don't have to write this down, but what I want you to realize is our original polynomial was 2x to the third plus 48x minus 2x. 2x to the third minus what? 48x what? Minus 2x. That is equal to our, it wasn't 48? Oh, minus 48 minus 2x. Okay. Got it. Okay, wait. This was our original one, right? That was equal to, our first factor was x plus 3, and our answer was, thank you. 2x squared minus 6x plus 16. This is equal to this because this was a factor and this was our answer, so that's the other factor. Okay, are y'all
Yes, we need to
seeing? No, we're gonna do some more, but I want y'all to understand the logic behind this. Okay? So if I said here is one factor, find the other factor. You could take that original polynomial, divide it by that first factor, and your answer is the other factor.
So we have to do all that again to get the second.
Well, hang on. I do have a shorter way. Yes, but you can't get away from long division. You cannot get away from long division all the time, but you can some of the time. It's called synthetic division. It's synthetic means fake. It's like fake division. It's like a shortcut to the division. It's used when the divisor, that means what you're dividing by, is in the form of x plus or minus some number. Which means, if it is divided by x squared plus something, you have to use long division. Or x to the third, you have to use long division. But if you're dividing by x to the first plus or minus some number, you can use synthetic division, and it's much shorter and it's much faster.
So we go ahead and then like this all in one equation or whatever, like find the second factor, you have to use synthetic division.
You should use synthetic division because it's a lot faster and it decreases the amount of mistakes you can make. Okay, so you should have written all this down last night. Here are the steps. Set the factor equal to 0 and solve. So, what does that mean? If we're dividing by x plus 3, we want to know what is the solution of that factor. So x plus 3 equals 0, so x equals negative 3, right? So, figure out what the solution is. What we're saying is we're checking this solution. Because once we divide, if we get a remainder of 0, then that means it was a factor, which means that it was a solution. If you don't get a remainder of 0, then it was not a factor, and it is not a solution to that equation. Okay? So, write the solution that you're testing and put it in a box. And now, I'm going to do several examples. Don't worry. Write out the coefficients of the polynomial in descending order and replace any missing terms with 0. We did that in long division also. Okay? Then, you drop the first number down underneath the line. Everything under the line gets multiplied to your solution. And then you write your answer in the next column and combine, repeat, like wash, rinse, repeat, wash, rinse, repeat. It's what we do for synthetic division. It's how it works. You'll get good at it, I promise. The quotient is your answer in a division problem, is always 1 degree less than what you were your original polynomial. Okay, so we're going to add back in our variables, and then we'll be done. And I know this makes no sense right now, but it will. In a minute, it will. So, okay. So, if I gave you this problem, you could do it using long division, right?
But you would have to factor out a solution, right? Because
We're not worrying about greatest common factors. We're not worried about that. Okay, so we're going to take this and divide it by this using synthetic division. And I can do that because what I'm dividing by doesn't have an exponent higher than 1. Okay. Yes.
That's the same.
Yes. So we know what the answer should end up being. So we're going to do that same problem now using synthetic division. It's going to be shorter. Okay. Okay. So this is what we're checking to see if it's a factor, right? So what is my solution that I'm checking? So, right, because we say x plus 3 equals 0, so x equals negative 3. That's my solution that I'm checking. I want to see if it's a solution. So, I'm going to take x equals negative 3, and I told you step 1 was put it in a box, so it's kind of a half box. Okay? Now, just like we did with the long division, we need to take our original polynomial and we need to put it in descending order and we need to put placeholders, okay? So, we know this will be 2x to the third plus 0x squared minus 2x plus 48, right? So just off to the side somewhere, make sure you write it out, put it in the right order, and add your placeholders. Yes?
how do you know when the added 0 x squared?
Because there's no x squared term. Every term below The highest exponent has to be represented. It needs a representative there. Okay? Can't leave anybody out. All right. So now, the next step was take all the coefficients. What does a coefficient mean?
The
The number in front. Take all the coefficients and we're going to put them right here. So, 2, 0, -2, and 48.
Yeah, I forgot.
We're not even looking at variables anymore.
This is.
Once they're all represented, they're not part of our calculations anymore. We're just going to add them back at the end. Okay?
Oh yeah, I forgot to ask you. What made us put the 0x squared in?
Because there was no x squared represented. Because remember with the long division, if we didn't put it, whenever you multiplied, there's no term that you could put it underneath.
So there has, if we're doing this synthetic long division and there's not an x squared.
You put a 0x squared in its place.
Every time.
Every time.
Where's like 2x to the 5th?
If it's 2x to the 5th minus 3, then you need plus 0x to the 4th, plus 0x to the 3rd, plus 0x squared, plus 0x. Every exponent below your highest has to be represented. Okay, so we put our solution that we're testing. We write our coefficients of our polynomial. Now, wash, rinse, repeat. Okay, so bring down the first number. Everything underneath this line gets multiplied to our solution.
Wait. I just lost.
Okay, bring down the first.
You lost me.
Bring down the first number.
Wait, but what are the x's in the square root?
We're not worried about those right now.
Oh, okay.
This is fake division,
Okay.
synthetic division, faux division. Okay,
That's price.
bring down the first number. Everything underneath that line gets multiplied to -3. Then once you multiply it, you put the answer on the next column. Then you combine these. Then you're going to have something underneath here. You multiply it to here. The answer goes in the next column. Then you combine them. Okay. Yes. Okay. So, bring down the 2. 2 times -3 is?
-6.
We combine these. You add or subtract them. 0 minus 6 is -6.
Okay.
Now we take it and we multiply it times. Everything underneath here gets multiplied. So -6 times,
18.
so that's positive 18, right?
18.
Combine,
16.
multiply,
Oh, I don't know.
-48. Combine. Your last number is your remainder.
Oh, so that, oh, wow. So,
Now, wait. Wait, I don't see the answer yet,
I
right?
do.
Oh,
Tell me, Nate.
okay.
So you put 2x in there.
It started with an x to the 3rd. Your answer has to start with one less than that.
Oh, okay. So it's
So this is x squared, and everybody's represented, right? X squared, then x, and that's a positive 16, so that's our constant.
Oh, wow, so much.
So this is my answer.
So what do you do with the remainder? We have like a
Okay, what did you do? What did you do with the remainder? 5 divided by 2. 2 goes into 5 how many times? 2? With how many left over? That's my remainder, right? So you put your remainder over what you divided by. Right, so if I had a remainder, then it would be, say my remainder was 4. Then it would be plus 4 over x plus 3, because that's what I divided by.
Divided by x plus 3?
Yes, yes. And we'll look at some remainders. But if I get a remainder of 0, was that a factor? Yes. Was this the solution? Yes. Okay, so, okay, so 2x to the 3rd plus 48 minus 2x equals my first factor, which was x plus 3, times my second factor, which was 2x squared minus 6x plus 16. Now, if I told you to factor this completely, if I wanted to know all the factors, I would check and see if I could do the AC method with this and see if it factors further. If I told you to solve this, my first solution is negative 3. And then I would have to take this and set it equal to 0 and solve that.
So how do you know which one to do?
You read your directions. The directions will say factor completely or it will say solve. If there's an equal sign in there, you're solving. No. If you're dividing it by x to the first power plus a number, synthetic division, you can do synthetic division.
So
If it was x squared plus 3, can't do synthetic division with that. Okay, let's do another one. What? Y'all need to hold on? Okay, so what is the solution that I'm checking? X equals positive 1, right? That's the solution that I'm checking. Okay, so I need to put this in the correct order. So 4x to the 4th, then I have to have my x to the 3rd term. So plus 5x to the 3rd, then my squared term, plus 2x squared, then my x to the 1st, which I don't have one, so that's going to be plus 0x, and then my constant, minus 1. So if it's x to the 4th, you need to have 5 numbers right here, because it's all your exponents plus your constant. Right? So if it's x to the 5th, you need to have 6 numbers right here. Okay, so maybe that'll help you to realize you're missing a number. Okay. Most of the time. Okay, and they'll probably not be in order. Okay? So, we put our coefficients. 4, 5, 2, 0, and negative 1. What mathematical operations are going to happen above the line? Addition or subtraction, right? Depending on their sign. Below the line? Multiplication. Okay? Think about it as being like the upside down division problem. Like when you divide everything on top, you multiply times. Never mind. Okay. So we bring down the first number because you got to have a starting point.
this is easy.
Okay. Everything gets multiplied times 1. So 4 times 1 is 4. Add these, we get 9. 9 times 1 is 9. Add these, we get 11. 11 times 1 is 11. Add these, we get 11. 11 times 1 is 11. Add these, we get 10. My last number is what? What is it, though? My remainder.
Okay, so
So it's not, we did something wrong now, right? Are we supposed to get a remainder of 0?
No, you shouldn't get, in this problem, you should actually have a remainder. No, all that means, what does it mean? I have a remainder. What does that mean about x minus 1?
You just gotta put it up under.
It's not a factor.
So would it be a yes or no question? Or would it be
is it no solution? If it has a remainder, did you say it's like no solution?
If it has a remainder, that just means that x minus 1 is not a factor, and that just means that x equals 1 is not one of the x-intercepts.
So we can get something that's not 0 and still be right on the problem?
Yes, yes. If the problem says divide using synthetic division, I don't care if you get a remainder. It's part of the answer. Okay. Okay, so my answer originally was x to the 4th, my original problem. So my answer has to start with x to the 3rd. That should make logical sense to you, because if I'm taking x to the 4th and I'm dividing it by x, my answer is going to be x to the 3rd, right? So it should start with one exponent lower. So x to the 3rd, then x squared, then x, then my constant. And the pluses or minuses are determined by whether those numbers are positive or negative. Okay? So when I write my final answer is 4x to the third plus 9x squared plus 11x plus 11, then my remainder. The remainder is part of the division. If you take 5 and divide it by 2, you can't just throw the remainder away. It's still part of it. So, plus 10 divided by x minus 1. So this is your answer. Now, that is not a factor. So, it wouldn't, if you had to factor that problem, that can't be done by dividing by x minus 1. Okay? Good? Okay, let's try another one. Try that one. Okay, so the solution that I'm checking is x equals 3. Thanks. Now, I have 1x to the 4th. I don't have an x to the 3rd, so that's 0x to the 3rd. And then minus 10x squared. And then plus 2x, and then plus 3. So, it's 1, 0, negative 10, 2, and 3. And I know whatever that is going to be my remainder. Right? Whatever that ends up being is going to be my remainder. So, bring down the 1. Multiply it times 3. Okay, combine these. When I say you add them, that means, depends on whether their signs are positive or negative, you're combining them, like combining like terms. 0 plus 3 is 3. Multiply, you get 9. Now we don't, negative 10 plus 9 is not 19. It's negative 1. Negative 1 times 3 is negative 3. That's not 6. That's negative 1. Then multiply that times 3. And when we combine these, we get 0. So, is x minus 3 a factor?
Yes.
Yes. Is x equals 3 an x-intercept?
Wait, no, yeah.
Is x equals 3 a root? Is x equals 3 a solution?
Yeah. I said, yeah, I was the only person that said yes.
What's the difference between a solution and a root? None. What's the difference between the solution and the x-intercept? None. Okay. So let's add back in our answers. So this starts with x to the 4th, so this has to be x to the 3rd. That's positive. So then it has to be x squared minus 1x minus 1. So recognize that x to the 4th minus 10x squared plus 3 plus 2x is equal to x minus 3, that's one factor, times x to the 3rd plus 3x squared minus x minus 1. Recognize that. Okay? Because even though this was our answer, that just means it's another factor. Okay?
Are you gonna maybe like have to find the other factor?
Yes. Okay. Try this one, and then I'm going to do an example like a homework problem that I don't want you to get confused by the instructions. So try this one. It's the same thing. Divide it however you want to divide it.
Yeah, that's long division. This is
So we have to do long division. Now, if you're going to do long division, which you don't have a choice, you still need to put your placeholders even in the denominator. Okay?
And so it's gonna be 3 numbers, so yeah.
Yes. But that's okay. You're only doing first number into first number. Okay. Hey, hang on. Okay, yes. So it's going to be x squared plus 0x minus 3 divided into. You have to put a placeholder.
Oh, this is going to take even longer.
No.
Do we have to factor in, do we have to, multiply? So let's say.
Okay, let's do it.
Let's say we have a number up
Listen.
there.
Shh. The steps are the same. Same steps. Okay. So it's going to go into x to the third plus 7x squared minus 3x minus 21. Okay, there was no missing terms in there. So you're still going to do the same thing. First term into first term. X squared goes into x to the third, x times. Now remember, we're multiplying x times all of that. Okay? So, what? Okay, so x times x squared, x to the third. X times 0x is plus 0x squared. X times negative 3 is negative 3x. Okay, like I said, the steps don't change.
Wait,
So now,
do we have to do subtract?
now we subtract, which means, what does subtract mean? Change all the signs of everything down here. So that's going to be negative x to the third, negative 0 doesn't matter, and positive 3x. Okay?
So everything's going to cancel
Your
out.
first terms are going to cancel. Everything else, if it cancels, you need to leave that 0 whatever. Okay? So, this is 7x squared. What is this? Negative 3 plus 3 is 0. So, plus 0x, then bring down minus 21.
I have a feeling we wait. Yeah, I would be stuck right
You can't do it with this one. Okay, so, we divide, multiply, subtract, we brought down. What do we do next? Divide again. So, x goes into 7x squared how many times? 7, so plus 7. Now what? Multiply. 7 times x squared is 7x squared. 7 times 0x is plus 0x. 7 times negative 3 is negative 21. Now what? Subtract, which means change all the signs on the bottom. So, negative, negative, positive. Everything cancels. So my remainder is 0.
So x plus 7 is.
So x plus 7 is the answer. Equals x plus 7. And it is a factor. And x squared minus 3 is a factor. Your homework has problems that look like this. Okay, listen. The first two set of problems say divide using synthetic division, divide using long division, right? But this says factor the polynomial given that f of k equals 0. What does that mean? That means f of negative 2 equals 0. That means when I plug in negative 2, I get 0. That means my remainder is 0. So, if my remainder is 0, is this a solution?
Yes.
Yes. So they're giving you a solution, and then they want you to factor it. This is telling us that this is a solution. So they want us to factor it. So, we're going to use synthetic division to figure out, we're going to get this down to an x squared term. Once we get it down to an x squared term, we can factor it normally. Okay?
I have a good question.
Yes.
So since that's okay,
It doesn't look like it. Okay, so k equals negative 2. Okay, if this is a solution, which they told us it is, what is that factor?
X plus 2.
X plus 2. The first factor is x plus 2. We're going to use synthetic division to find another factor. So, our coefficients are 1, negative 5, negative 2, and 24. I know I'm going to get 0 for my remainder because they told us that's the solution. So, bring this down, we get 1. Multiply 2. Combine, negative 3. Multiply, negative 6. Combine, negative 8.
1 times negative.
What did I do?
1 times negative 2 is negative 2.
That's negative 2. So that's negative 7. So that's,
Positive 14.
thank you,
Then you get
because that's negative 2. That's positive 14. That's 12. That's negative 24. That's 0. Okay. You had to get 0. For these set of problems, when you do synthetic division, you have to get 0. Okay? Because f of negative 2 is equal to 0. Okay. So, our first factor was x plus 2. Now, our second factor is
1x squared.
1x squared, because when we add these back,
7.
minus 7x plus 12. No, it's not. So, but they want us to factor this completely. I'm done with the division now. I can factor that. That's a trinomial. That's a trinomial.
Okay.
AC method. No. No.
I don't want the long though. Anytime you want
Okay. Okay. We're running out of time, so we need to focus. So these set of directions said factor the polynomial given that, basically this is saying giving that what the value I'm giving you is a solution. So that's what you do. Okay? They just want you to factor it. They don't want you to find the other solutions, but what if it did? What if it wanted you to find all the solutions? My first solution is,
Negative 2.
my second solution is, and my next solution is 3. Okay? Any questions? Okay. The next problem is in your last set of problems in the homework, and it's basically factor and solve. So it's the same thing, but they want you to tell the solutions at the end. Okay, but this is how it words it. What's a 0? A 0 is a root, is a solution. Okay, that's why I've been saying this over and over again. I want y'all to get used to this terminology. So, given 1 0, so this is our 0, which means it's a solution. Solution is the same thing as a 0. Given 1 0 of the polynomial function, find the other zeros, which means find the other solutions. Okay? So, since they gave us one solution, we can use synthetic division to factor it. So, our first solution that they gave us is x equals negative 2. So now we're going to do just like we did before. We're going to factor it, and once we factor it, our answer is going to be a quadratic. It's going to be x squared something something. And then we can factor that using either AC method, or if we can't do the AC method, we can solve that quadratic using quadratic formula. Okay? So, our coefficients, I don't need any placeholders. So it's 9, 10, negative 17, and negative 2. So bring down the 9.
But it can't be,
Multiply. You shouldn't get a remainder. Multiply, you get negative 18. Combine, you get negative 8. Multiply, you get positive 16. Combine, you get negative 1. Multiply, you get positive 2. Combine, you get 0.
0.
Okay.
Yeah. I like this one.
Okay. So my answer is going to start with x what? X squared, and then x, right? So, what's my first factor? X plus 2. My first factor is x plus 2, because they told us the solution was negative 2, so the factor has to be x plus 2. My second factor is 9x squared minus 8x minus 1. Okay? Do the AC method with your trinomial. So A times C is 9 times negative 1, which is negative 9. And my two factors are negative 9 times 1. So that's 9x squared minus 9x plus x minus 1. Okay? And then we group. So take out a 9x, right? So you're left with x minus 1. Take out a 1, you're left with x minus 1. Notice I'm not losing this factor every time, because it's part of the answer. So that's 9x plus 1 times x minus 1. It's factored. How do we find a solution?
Equal everything to 0.
You take each one and set it equal to 0. So, x plus 2 equals 0. 9x plus 1 equals 0. X minus 1 equals 0. So x equals negative 2. That's one root. That's 1 0. What's wrong?
Isn't it negative one?
Yeah.
So like open this. Oh, hi, that is a lot.
That's so much fun. It's fun. Somebody thinks it's fun. A little bit.
Fun for you. Great. I don't think I've ever been.